2021. Thanks a lot to the organization for having us today. So let's meet. What are we going to talk about and who we are? Werner.
I'm the current committee member in the Jakarta specification committee, and I work for clients, everything from Eclipse RCP, IoT, to the back end, especially Jakarta of course.
Nice, cool. A few words about myself. Thodoris Bais is my full name, or Thodoris Bais in English, originally made in Greece, living and working in the Netherlands for the last 6 years. I have the honor to be the founder and leader of the Utrecht Java user group. And besides, I also like helping others achieve their goals in career and life via my own company, Agile Leaders. Otavio.
Hey, I'm glad to be here. My name is Otávio Santana. I'm the senior engineer at Zoop Innovation, who is a company who has several products that includes open source products to make your life easier in the open source, especially cloud native one.
Cool, nice. So, after the necessary round of introductions, all of you must have already seen that we're going to talk about NoSQL Endgame today. What are the 5 main trends in 2021? First of all, more customers are going online. Second trend, the internet is connecting everything nowadays. Third trend, big data is getting bigger and bigger. Fourth trend for 2021, apps are moving to the cloud. And last but not least, the world has gone mobile. I'm pretty sure, though, many of you are already wondering what do these trends mean for us? And that means that new digital trends create new technical challenges. So what are mainly these challenges is the question that might already come up next. First of all, agile development process, right? High performance and availability. And third, of course, how to manage huge data volumes. Don't worry, we already have the solution for you. It is NoSQL, of course. So what are the main advantages of NoSQL nowadays? First advantage, it can handle large volumes of data at high speed. Second of all, it stores structured, unstructured, semi-structured, or even structured data. It's easy to update schemas and fields. My favorite one, it is developer friendly, and of course, it takes advantage of the cloud to deliver zero downtime. Now, at this point, why the rationale behind this talk is a question that might also pop up. Our beloved JVM can cope with heavy loads. And of course, there is a bunch of persistence frameworks available out there. But here comes the question. Which one of these performs best for your case? It will normally take ages for you, also for us to compare. So that's why we already did it, and we are here to further discuss our findings. We're gonna talk about NoSQL, which is of course a database that uses semi-structure or doesn't use structure at all. It has no transactions. It is based on the base concept, which Werner will further discuss later on, and it mainly has 4 different types. Werner, which are those types?
Well, first of all, there's key value stores, including the likes of Amazon S3, Redis, or Hazelcast. Then there are the column-oriented systems, including Cassandra, HBase, or DynamoDB. Document stores, MongoDB is probably the most well known, but there's also Couchbase or the open source version Apache CouchDB. Then there are graph databases for relationships that are often much more sophisticated than you might be able to accomplish in a traditional relational database world, including Neo4j to be the most well-known. Yep. And then there are, of course, so-called multi-model systems where you support one or the other type, or sometimes even up to 2 or 3. Like OrientDB supports graph and document, Couchbase does key value and document, ArangoDB even does all 3, or Elasticsearch supporting document and graph. So what's the main difference in acronyms and terms? So in the traditional SQL world, we have tables, rows, columns, and relationships. Key value has a bucket and also the key value pair. The column-oriented is a little closer to what SQL offers, especially with the column and column families. Documents have collections, documents, and again, a key value pair, while graph is much different from all the others, using terms like the vertex and edges. So you see there's a lot of diversity and not so many overlaps. The base principle that NoSQL databases apply stands for basically available, soft state, and eventual consistency, while traditional SQL databases apply the ACID principle: atomicity, consistency, isolation, and durability. Then there's CAP, consistency, availability, and partition tolerance, where various systems fall in different areas. For example, Cassandra being highly available and partition tolerant, MongoDB being consistent and partition tolerant, and we have traditional SQL systems like MySQL or MariaDB, which can offer high availability at the cost of some of the others not being so strongly represented. The same goes for scalability as opposed to complexity. The key value systems are very scalable, while on the other hand, the graph systems are the most complex one. And just looking at what happened at Facebook, since Facebook has a lot of graph-based systems in their timeline, you can see if there's a failure, it sometimes affects users around the world. And so that's pretty much the same with NoSQL databases in some cases, or most of these companies actually use them. With the relational approach, you have a DAO, then you usually have JPA, and underneath JDBC and the actual physical database systems. With NoSQL, the DAO might be the same, but then you have a lot of different APIs that are often not really compatible with each other. So that's why we are looking at some of the popular frameworks like Spring Data, Jakarta NoSQL, and its compatible implementation, Micronaut, as well as Hibernate. And we also compare them with different NoSQL database systems. Although here, for the sake of time, we are not showing any live demo, but we will also quote some of the code. So what's the problem using JPA for NoSQL? Well, it saves asynchronously, and there are also asynchronous callbacks, the time to live, the consistency. It's SQL based, which sometimes doesn't always work, especially when you have something like a graph database. And as we already noticed, there's often a large diversity in NoSQL systems, so that one query doesn't always work for all of them. Jakarta NoSQL and several others use the concept of annotated entities. So that's something that sounds a bit familiar to what you might know from SQL. But there's also the template approach that Spring Data has been very good at and has practiced for quite some while. That's also offered by Jakarta NoSQL in a similar way. And then there's the repository pattern. Here again, an example using MongoDB. And here you see that the difference is basically just the database type. Other than that, they are practically the same. You can embed queries in a repository. That's a bit like using prepared statements in JPA. And there are also, in some cases, specific annotations for systems that require different treatment. For example, for Cassandra and other systems, there are often additional annotations that are specific to that particular environment. Query by text, that's probably the closest to what you might know from SQL. And now let's look at how Micronaut does that. There's Micronaut Data, but at least at the moment, it's not yet fully supporting NoSQL systems. But nevertheless, it has support for a handful of popular systems, especially Neo4j or MongoDB. So here's a repository pattern. We have entity classes that are essentially POJOs. And unlike some of the other competitors, Micronaut currently does not require annotation. So it's even more plain than some of the others. There's query by text, similar to what we have seen before with Jakarta NoSQL. And then, of course, Micronaut was inspired by the people who created Grails and Groovy before. So for the Groovy and Grails world, there has been GORM, which is in a similar position. It doesn't have one layer for every single NoSQL database, but it has a couple of good integrations with MongoDB and a few others. The annotation works pretty similar. Here again, with Java annotations on top of entity classes.
And I guess
And
that
now it's up to you, Todores.
Yes, I guess that concludes already our beloved GORM. So let's see what happens with Spring Data MongoDB, right? Let's split it in two parts, I would say, the logistics and the domain. Let's start with the logistics, of course. Nothing crazy, no rocket science there either. So just a very simple dependency in your POM XML file. Of course, for the sake of these demos, Otavio will later on share the links to the repositories. So for the sake of these demos, we are just using the Spring Boot Starter Data MongoDB dependency, and of course, another properties file. Of course, we have to connect to the mythology database, and of course, the standard 27017 port for MongoDB. Let's see what happens with the domain, though. Same goes here, just a framework-specific annotation for your domain classes. So in our case, we annotate our domain classes with the annotation at document, and in parentheses pointing to the corresponding collection of data, of MongoDB. Same goes for the repository, as Werner has already shown you earlier. We just need to extend our repository from the framework specific repository, in our case, the Mongo repository. What about the controller though? No magic needed there. You write the controller as you're used to writing standard REST API controllers. That would be all about the configuration of Spring Data for MongoDB. Let's see what happens for Neo4j. Neo4j comes by default or ships by default with a movies database. And you can here see a very standard, a very typical example where Tom Hanks is a person that is a node, in our case, in our graph databases. And then you have some relationships, right? An entity has a relationship to another, a node has a relationship to another node. In our case, another node could be a movie. The relationships here acted in. Another relationship could be directed. So person Robert Zemeckis directed movie Forrest Gump. More you will be able to find in our examples again. What about the logistics and the domain though? Same goes here, just a dependency in your POM XML file and your credentials in your properties file about connectivity, of course. What happens with the domain though? Again, here, movie entity and movie repository. These contain your repository and your node classes. Same goes for the other node, which is the person entity in our case, and of course some roles class that needs to define the relationship between the different nodes. In code, here is how we would code it with an at node annotation for the person, and of course in parentheses the name of the node that it corresponds to. Same goes for the movie entity, again a node, and of course important here is the add relationship with the different types and directions, of course, according to what you want to map to. The repository, again, extends from the framework-specific repository. Same goes for the last roles class that connects the different nodes together. Just an add relationship properties for that class. That would be all. Please have a look at the examples. Ottavio, what about Hibernate?
Yeah, Hibernate is a good question, right? Because what happened with NAN? Basically, the whole idea of Hibernate is okay, the developers already know JPA, why not use that with NoSQL database? And here you go. So as you can see here, the sample where we are using JPA annotation to integrate with MongoDB. When you go to the next slide, as you can see a transaction manager, transaction begin, the manager factory. So everything is pretty similar to JPA. And that sounds like a good idea, right? Unfortunately not, especially because yes, MongoDB has support to transaction. However, through the documentation is not a good idea, especially because it give you a huge nightmare when you talk about performance, right? So the whole point is knife is knife, fork is fork, SQL is SQL, and NoSQL is NoSQL. Maybe because of that, there is no update since 2018, I guess. But here you go. Let's go to the conclusions of these comparisonships today. The first one, the NoSQL, it's still in progress. Yes, it does. It removes a lot of boilerplate and provide a cleaner, more readable DAO, data access object. It has support number of NoSQL database, especially because they Tinkerpop. Uh, let's move on to the next one, Micronaut. It is still in progress as well. It's hard to switch between NoSQL vendors. Micronaut Data does not support NoSQL database yet, at least has a slight support to MongoDB. However, it has a nice footprint and a polyglot language support, such as Java, Kotlin, and Groovy. The next one, GORM. Indeed, it does. It removes boilerplate a lot, provide a cleaner implementation to make the Java developer life easier. It has support to polyglot language. However, if you take a look in the most popular NoSQL database, it has support to of four. It's still a good number. However, it's you need to move on to get more support. The most popular one, and my perspective, the most mature one is Spring Data. So it removes a lot of boilerplate. It has a cleaner and a nicer DAO implementation that includes the repository as well. It's really, really easy to switch between NoSQL database, especially thanks to Spring Data. Uh, it has not all as possible as Jakarta NoSQL has, especially because the Tinkerpop. Again, Jakarta NoSQL has a huge amount of NoSQL database because Apache Tinkerpop, and Eclipse does not have this kind of support. However, it's the most mature one. It is the one who has more success case, and that's why a lot of API of Jakarta NoSQL brings from Spring Data. And the last one, Hibernate, is outdated, unfortunately. There's no update since 2018. The idea was great, however, in the practice, it's a little bit harder, especially because NoSQL has several particular behavior that does not have support to the API, and it's hard to find several errors and stuff like that. And that's it. So Hibernate OGM to me is not recommended as solution to use with NoSQL database. If you want to know more, if you want to get more information, please take a look on this link here. So GitHub repository, where you can go to JNOSQL and NoSQL Endgame. If you want to know more about the standards around Java and NoSQL, please go jnosql.org. Thank to several people who help us. So Mike, Mikkel, Simon, Jan Tessier, and Fratikon. And that is it. So thank you, everybody. Hope that you enjoyed the show, and hopefully see you soon and physically. Bye.
Thank you, everyone. See you later.